This is Mr. Anderson for Kellogg Community College, and we're going to look at complex numbers today, and more importantly, imaginary numbers. If you try to take the square root of negative 64 in your calculator in real mode, your calculator will spit out an answer that says, sorry, in real mode, all answers must be real. And what we need to explain is that you can't take the square root of a negative number because the square root of a negative 1 is imaginary. It is the letter I. And I want to basically highlight the fact that we are going to take all of our negative square roots and break them into the integer times negative 1. And what this is going to do is give us the answer of 8, because the square root of 64 is 8, and the square root of negative 1 is I. So my answer is 8I, and I wish to make this statement that for the sake of this video, all roots will be positive. We're not going to consider positive or negative we're not going to consider positive or negative possibilities, and that is going to be further explained in the third video in this complex numbers series here, because we just want to focus right now on getting the answer right with the negative under the radical. So, for example, this negative 128. This can be broken into three, or be made into the product of three different numbers here. 64 is the best way to simplify negative 128 times 2, because 64 times 2 is 128 times negative 1, which gives me my 8 square root of 2I, which is rational, irrational, imaginary. I'm going to use that format, and I have seen a few books put the imaginary number between the two of these, but I prefer this order. I think rational, irrational, imaginary is the best way to go, because it fits the A plus B I format. It also I just fits more books. But I wish to say that please make sure that you draw the I separate from the square root, because the square root of negative 1 is I, and I want you to avoid writing the square root of I in any shape or form. So if you don't put the I back under the square root, the definition is the square root of negative 1 is I, not anything under the radical here. So when I look at the square root of negative 108, the biggest number that can divide negative 108 that's part of a perfect root is 36, and that's multiplied by 3 to get to negative 108 times negative 1. The product of these three things make negative 108, but it also breaks this down into 6 square root of 3 I. And you'll see that the I is not inside the radical, nor will it ever be. So there is that answer to the problem. Now the next 5 examples I have here are going to try to trick you. It's going to try to use some algebra, it's going to really try to see if you know your algebra rules versus these radical rules. Because one of the common mistakes if you don't know your radical rules is that you just say, okay, 2 negatives make a positive. Not in this situation. In this situation, this negative is inside the radical, so it is not going to be communicated or just brought to the outside, not at all. So this negative 121 is the same thing as positive 121 times negative 1. The negative that's right here stays outside of the square roots, waiting for the answer to occur. So the negative stays out in front. The square root of 121 is 11, and the square root of negative 1 is I. So my answer to this problem is negative 11I. Another problem to trick your senses here is to see if any of you took the bait and called this answer 0. Sorry guys, you cannot add the insides of radicals together. As shown in previous videos about radicals, you cannot say, alright, I'm going to take the square root of 16 and add it to negative 16. Now, it doesn't work that way. And these radicals would have to be exactly the same for us to combine them. So here is 4, and here is, if I break this down into the square root of 16, wow, that looks a little crappy there. Sorry about that. Square root of 16 times square root of negative 1. This is going to be a positive 4i. Now, will you combine this to make 8i? Will you combine this? No, you can't. This is actually the end of the problem. 4 plus 4i is the end. You cannot make that 8i. For the same reason you couldn't take 4 plus 4x and make that into 8x. And so let's also talk about this is 4 things and this is 4 imaginary things, and that wouldn't make them 8 imaginary things. That is the answer, 4 plus 4i, or 4 4 plus 4 times the imaginary I. Yeah, any way you want to look at it. Don't combine these. For this problem here, we are going to split this up and try to reduce that radical as much as possible. So 16 times 3, or 4 square roots of 3. We're going to break this radical up as much as possible, which is 9 times 3, and times negative 1. So this is 3 square root of 3i, and so we subtract these two. So here I have 4 square root of 3 minus 3 square root of 3. Now, if it was just that, if it was 4 square root of 3 minus 3 square root of 3, then my answer would be 1 square root of 3, or just square root of 3. But this has an I at the end of it. Could we combine these now? And the answer is no, you can't combine them. You can't combine these at all. You're done with this problem, because this is like saying 4x minus 3xy. You can't combine 4x minus 3xy together, because this would be an xy, or in this case square root of 3i, and this is square root of 3. You can't put these together, and I know you want to. I know you really, really want to, but you can't. You can't do it, so that's the end of that problem. Knowing when to stop is pretty much a challenge in itself. Alright, let's do these two, and then I'll scroll down for the bottom part, the end of this video, which is adding and subtracting these complex numbers, or numbers with imaginary numbers in them. So let's split this up. This is going to be 4 times 6, which is 2 square roots of 6. Let's split this up, which is going to be 49 times negative 1. So we got 2 square root of 6 minus 7i, and we're done. There's nothing else you can do with this. Like if you had 2x minus 7y, you couldn't combine the 2x and the 7y together. You're done. You've got your rational, irrational, and imaginary in that order. So for our final problem, let's split this up. We can split this up into 25 times 6. We can split this up into the square root of 9 times square root of 3 times square root of negative 1. So this becomes 5 square roots of 6 minus, this becomes 3 square root of 3i. And we're done. And we're done because you can't combine these. You can't combine a non-I with an I. Now, you're probably going like, well, gosh, when are we going to get to combine them? Well, down here you will, because we're going to add and subtract these complex numbers. And you can add whole numbers to whole numbers, and you can add i's to i's like you would variables. This is a quick reminder that, x plus x is not x squared, it's 2x. So likewise, I plus I is equal to 2i. These imaginary numbers have properties like variables. So in this case, the parentheses are there for decoration, showing you the a plus bi format. So if I take the 4 and the 7, add those together to make 11. Losing 6 and losing 3 is like losing 9i, and we're done. That problem is finished. That is the end of the problem. Over here, 7 plus 5 is 12, and negative 4i plus 3i is negative 1i, or just negative I. Don't put a 1 in front of the I. We don't put 1s in front of x's as our final answer. You may have had a professor or teacher do that to you to show you where it is, but truly simplified mathematical answers should not have a 1 in front of the x, or in this case, the I. Okay, so in this problem we're not adding, we're subtracting, but this is a reminder to quickly distribute the negative. So negative 12 plus 11i is the correct distribution of that subtraction. So 6 minus 12 is negative 6, and negative 10 plus 11i is positive 1i, which is rewritten as positive I. Again, don't put the 1 in front of the I for the final answer. Here there's no distribution. This is just 9 minus 2i plus 1i, and 9 minus 2i plus 1i is negative I. Now this problem here, 3 plus negative 3 is 0. 4i minus 4i is 0, so your answer is 0. Please do not draw a line through this. That's empty set. Empty set is different than 0. Empty set is like saying there is no answer to this problem, but there is an answer to this problem. The answer is 0. There is nothing left. 0 is the answer. Whew. So for our last example, in the end of this video, clocking in just at 10 minutes, we're going to take 8 minus 6, which is 2, 3i minus 4i, which is going to be negative I, and that's it. That is the end of the video, taking our first two parts here about figuring out what a complex number is with the imaginary numbers, and also writing down just simple addition and subtraction. In part 2, you will see multiplication and rationalizing denominators. Thank you very much for watching.